Today we'll go for how to calculate the cell potential of a cell. So here we'll go for the next part of the electrochemistry. So we'll go for the next part of electrochemistry. So here I will go for how to calculate the cell potential of a cell. So the cell potential is represented by E cell. And what is cell potential? The cell potential is nothing but the tendency to flow the electron from one electrode to another electrode. This is, let's say, one electrode and this is another electrode. And I want to just find out the tendency to flow the electron from this electrode to this electrode. So when electrons start to flow from this electrode to this electrode in a closed circuit, then we can detect the cell potential. So let's say this is one of the cell, this is one of the half cell, and these two half cells are connected by the help of a salt bridge, and we are taking some electrolyte here also we are taking some electrolyte. And this is one of the electrode. From this electrode, electron is flowing to this electrode, so that indicates that this electrode undergoes oxidation. So here the tendency to release electron is the part of oxidation potential. And here this electrode wants to accept electron, because here electron is moving here. So the tendency of this electrode to accept electron is the nothing but your reduction potential. So what I told about the cell potential, I told the tendency to flow the electron from one electrode to another electrode. And the unit which we are using to measure the oxidation potential or reduction potential or cell potential, whatever may be, then we are using the unit is volt. Let's say the oxidation potential of this anode is, let's say, X voltage, and the reduction potential of this cathode is, let's say, Y voltage. Then what will be the cell potential? I can say the cell potential for this cell is your X plus Y voltage. Means I can say that is the oxidation potential which is taking place at anode. So I can say that is the E of oxidation, that is the oxidation potential where at anode, and Y voltage is the reduction potential at cathode. So I can say that is your E of reduction potential at cathode. So I can say what is the formula to calculate the E cell. The formula to calculate the E cell is your E oxidation potential at anode plus E reduction potential at cathode. So this is the general formula to calculate the E cell. Now I can represent this E cell in different method also. Why? Let's say I am writing a reaction here at the anode. Let's say this is the anode, and at anode, let's say the reaction is going on, zinc undergoes oxidation. So when the zinc undergoes oxidation, then it gives, let's say, Zn2 plus 2 electron. So I can say its oxidation potential value, as it is anode, I can say its oxidation potential is nothing but your E of Zn2 plus. So that is your E of oxidation potential. Where it is? It is at anode. Now I want to write this equation in other form also. I want to write this equation like that: minus of Zn2 plus 2 electron give rise Zn. So I am writing like this way. So what it indicates? It indicates I have written minus Zn2 plus minus 2 electron give rise minus Zn. So if I want to just reverse it, then it becomes Zn, and this 2 becomes Zn2 plus 2 electron in the right hand side. So this and this both are same. But here what I have written, this is the part what I am writing is I am writing as the reduction tendency. That is the reduction part I have written. Zn2 plus 2 Zn means oxidation number decreases. What I am writing with a negative sign. So I am writing with a negative sign. So when I will write with a negative sign, then I can write that is your minus E of Zn2 plus 2 Zn. So I am writing minus E of Zn2 plus 2 Zn. So that is nothing but is your E of Zn2 plus, both are at anode. Both are at anode. So both the reactions I am taking at anode, but what I am writing? This is I am writing oxidation potential, and this is I am writing the reduction potential. So I can write now E oxidation potential at anode is equal to minus of E. This is the reduction potential I have written. So minus of E reduction potential at anode. So I can simply say that E oxidation potential at anode is nothing but is your minus of E reduction potential at anode, because this is the oxidation potential I have written and this is the reduction potential I have written. So both are in anode. So I can say E oxidation potential at anode is nothing but is your minus of E reduction potential at anode. So in the same way I can say now E reduction potential at cathode will be minus of E oxidation potential at cathode. So this is one I got, and another I told, that is E oxidation potential at anode is equal to minus of E reduction potential at anode. Now by using these two I can write this equation in another two form. So how will write? Let's say instead of oxidation potential at anode I will write minus E reduction potential at anode. So if I write this one, then how can write? I can write E cell is equal to, instead of oxidation potential of anode I am writing that is minus E reduction potential at anode. So I can write minus E reduction potential at anode plus E reduction potential at cathode. So that can be written as, so this can be written as E reduction potential at cathode minus E reduction potential at anode, and both are the same value. So this is the another form I can write. Now in another form what can I write? In another form I can write instead of reduction potential at cathode I can write that is your oxidation potential at cathode also. So if I'll write this one, then I can write what is E cell. E cell can also be written as E oxidation potential at anode, and instead of reduction potential at cathode I will write this one. So if I write this one, then I can write that is minus E oxidation potential at cathode. So those are the three top methods by which we can represent the E cell. So I can write what is E cell. E cell is your E reduction potential at cathode minus E reduction potential at anode. Or I can write E cell is your E oxidation potential at anode plus E reduction potential at cathode. Or I can write E cell is your E oxidation potential at anode minus E oxidation potential at cathode. So out of these three you can remember any one to calculate the cell potential. If I will write in this reduction potential, what it indicates, already we know at cathode the reduction takes place, at anode the oxidation takes place. So when I will go for the reduction potential tendency, I will go for the potential difference of reduction potential difference of cathode and reduction potential difference of anode. Similarly, if I want to go for the oxidation potential tendency, I can say the potential difference of anode and cathode with oxidation, because we know at anode oxidation takes place, so oxidation potential of anode is more than the oxidation potential of cathode. So here in another term of electro potential or cell potential can be called as, it is the potential difference between the two electrodes. Look it, this is the potential difference between the two electrodes in terms of reduction potential, and I have written this is the potential difference of two electrodes in terms of oxidation potential. So you can use any one for its calculation. Now what I have written the cell potential, this is the cell potential we can calculate in any condition. But when we will calculate the cell potential at the standard state temperature, that is the 25 degrees Celsius, under a pressure of 1 atm, and when the concentration of electrolyte is taken as 1 molar, then it is called standard cell potential. And this standard cell potential can be represented as E naught. So if we will write this is E naught cell, that is the standard cell potential. Under that condition, that should be also E naught, that should be also E naught. So if I will write this is E naught, then it should be for all E naught, like that. So what is the difference between the E naught and E? E naught is the standard cell potential and E is the cell potential. standard cell potential calculated under some specific condition, that is the temperature is 25 degrees Celsius, pressure is 1 atm, and the concentration of the electrolyte we are generally taking as 1 molar. So now let's say I will take one examples. I have written E naught of Zn2 plus is, let's say, 0.76 voltage. If I write E naught of Zn2 plus is 0.76 voltage, then I can say E naught of Zn2 plus to Zn will be just negative of it. So that will be minus 0.76 voltage. So this is the oxidation potential of zinc and this is the reduction potential of zinc. But always you have to remember, under the standard condition, that is the E naught, if you take H plus to H2, that is the reduction of hydrogen. H plus to H2 means hydrogen oxidation number here is plus 1, here hydrogen oxidation number is 0. So that is plus 1 to 0. This reduction potential value of hydrogen is 0. Similarly, E naught of H2 to H plus, its oxidation potential value is also 0. This value you have to remember for the numericals. So on the next class I will tell how we can use those terms for the calculation of cell potential by using the oxidation potential and reduction potential value, which we can apply from the chart or from the given data. So on the next class we will go for numericals of the cell potential.